In this lesson, we'll be looking at end behavior asymptotes for rational functions. The end behavior of a function f of x describes the value of y as x approaches infinity or as x approaches negative infinity. We often refer to the x approaching infinity as the right-hand behavior and x approaching negative infinity as the left-hand behavior. The reason we talk about that is what we're really looking for when we talk about end behavior is what happens to y for really, really far values on the right-hand side of the graph. And in particular, we're looking for, does it rise, does it fall, or does it level out and approach some specific y value? We do the same thing on the left-hand side. So today our lesson will evolve around trying to figure out what exactly is going on with the y for large values of x on the far right-hand side and on the far left-hand side. From our previous work with rational functions, we discovered that the lead terms of the numerator and denominator can determine the end behavior of a rational function. For example, in our first problem today, if we look only at the lead terms of this numerator, the lead term is the highest power of x, so 5x squared. Highest power in the bottom would be an x cubed. If we look only at those two terms, we can determine the end behavior of this more complicated fraction. By looking just at the lead terms, we would have 5x squared and x cubed. Now that's a pretty simple fraction, and it can be reduced since x squared is a factor of both numerator and denominator. We can reduce that to 5 over x. And what we want to know is how that behaves for large values of x. So let's consider for really big values of x, what's going to happen to 5 over x? A really, really large number in the denominator of this fraction, when 5 divided by that really, really large number, would become a really, really small number. So as x approaches infinity, 5 over x approaches 0. It becomes smaller and smaller. And the same thing actually happens on the left-hand side. As x approaches negative infinity, 5 over x also approaches 0. And since both sides approach 0, we say that this graph has a horizontal asymptote, and it happens at y equals 0. Now we can generalize this idea a little bit farther by thinking about this. In this particular example, we had a degree of our denominator which was larger than the degree of the numerator, and any time that happens, we're going to have a reduction of our lead terms, much like this, where an x will be left over in the denominator but no x is left in the numerator. So we can say in general terms that if the degree of the denominator is greater than the degree of the numerator, then we're going to have a horizontal asymptote. And it's going to happen at y equals 0. And again, we know that because this expression 5 over x here behaves in the same way for the far ends of the graph as this very much more complicated equation does. So that's our first example. Let's take a look at our second example. And again, if we consider our lead terms here, our lead terms in the numerator, 5x squared, in the denominator, 2x squared. So let's go ahead and write those things down. If we write 5x squared over 2x squared, keeping in mind that this more complicated fraction behaves on the far left and far right in the same way that this one does, this fraction can be reduced to 5 over 2. And we want to know what happens to that for large values of x. So I want to consider again, as x approaches infinity, what does y do? Now if you look at this fraction here is 5 halves. There isn't even an x on it. So x certainly is not going to play a role at all in the behavior of 5 halves. So for large values of x, y, it's just going to be 5 halves. It's going to stay the same. And of course the same thing will happen on the left-hand side. Y will be 5 halves as well. So we're going to say, just like we did in the first one, that this one also has a horizontal asymptote, and it's going to happen at y equals 5 halves. Now, just like in our first example, we can generalize this as well. We can say something like this, looking at this example. If the degree of the denominator is exactly the same as the degree of the numerator, this too is going to have a horizontal asymptote. And it's going to happen at y equals the coefficients that come from the numerator and the denominator. I'm just going to write that as y equals coefficients. Now our third and final case we're going to have to address with a new podcast. So I'd like you to go ahead right now and run podcast number 3, and then we'll discuss what happens in our final case.